A powerful model is not the same thing as a powerful agent. The model can reason, write, and recommend. But something else decides what it can see, which tools it can use, how it edits files, whether a dangerous command needs approval, and when the task is actually finished. That surrounding system is the harness. DeepSeek has now released its own open-source version, DeepSeek Harness. And its importance is not that it creates another chatbot. It is that DeepSeek is moving into the layer that turns intelligence into action. DeepSeek summarizes the idea with a simple equation. Model plus harness equals agent. The model generates decisions. The harness connects those decisions to an environment. It supplies the system prompt, the files, the shell, the tools, the memory, the approval rules, and a loop that asks the model what to do next. This is why the same model can behave very differently inside two agent products. One may lose context, misuse a tool, or stop after suggesting a fix. Another may inspect the repository, edit the code, run the tests, read the failure, and continue. The intelligence may come from model, but the reliability of the work increasingly depends on the system around it. That makes DeepSeek Harness a strategic move up the software stack. A model provider controls the intelligence and the price of inference. A harness provider influences the workflow, how developers connect tools, preserve sessions, supervise actions, and build entire families of agents. Claude Code is the obvious reference because it demonstrated how valuable a polished coding workflow can become. But DeepSeek Harness is not simply presenting another closed box with a different model inside. It is exposing the machinery as an open, configurable runtime. That changes the question. The competition is no longer only who has the smartest model. It becomes who defines the environment in which those models work. If developers build tools, policies, session systems, and custom agents around one harness, that layer can become more durable than any single model release. DeepSeek's answer is built around one unusually aggressive principle. Everything is a plugin. In many products, a plugin means one extra tool attached to an otherwise fixed agent. Here, the model adapter is a plugin. The tool registry is a plugin. Skills, sessions, storage, the file system, the sandbox, scheduling, and the user interface are plugins. Even a session log and the agent loop can be replaced. The goal is not to create one perfect agent configuration. It is to create a common frame in which different configurations can be assembled. A local file system could be exchanged for a remote execution environment. A model provider could be changed without rebuilding every tool. A different approval policy or context strategy could be mounted beside the existing parts. DeepSeek's architecture documentation says there is no privileged product core that developers must patch to make these extensions. Instead, capabilities meet through services and events, while configuration decides which pieces are active. Harness is therefore less like one finished agent, and more like a modular runtime for constructing agents. But radical modularity creates a difficult problem. Removing code is easy. Removing everything that code changed is not. A plugin may have registered a tool, attached event listeners, open resources, and provided services that other plugins now depend on. Replace it carelessly, and the old listeners may survive. Tools can appear twice. Dependents can keep calling a provider that no longer exists. Restarting the entire process clears the mess, but it also destroys useful in-memory state and interrupts ongoing work. For an agent that may eventually inspect or modify its own runtime, ad hoc cleanup is not enough. The system needs a disciplined way to reverse effects and react to changing dependencies. That is the job of Cordis, the plugin kernel beneath DeepSeek Harness. Its paper describes the idea as spatiotemporal composability. The phrase sounds abstract, but it separates two practical guarantees. Temporal composability asks, when a component is removed, can the system reverse the effects that component introduced? In Cordis, Context-mediated effects carry cleanup operations that the runtime tracks and applies during teardown. Spatial composability asks a different question. When a dependency appears, disappears, or changes provider, can the components that rely on it respond correctly? A dependent plugin can remain inactive while a required service is missing, deactivate when that service is withdrawn, and reactivate when a compatible provider returns. Together, these mechanisms aim to make the inside of a live agent replaceable without treating every change as a full restart. Cordis also supplies configuration reconciliation and hot module replacement. The important point is not that every computation becomes reversible. It is that changes made through the managed context have an explicit life cycle, and dependencies become something the runtime can observe and coordinate. Harness applies the same systems thinking to the agent's history. What the model sees and does is recorded in an append-only event log. Prompts, model output, tool calls, results, subagent activity, and context injections. Resume, fork, search, replay, and the trajectory view all derive from that stream. The release also ships 4 presets. Standard mode provides the full coding agent toolkit. Code, or PTC, mode lets model-generated TypeScript coordinate multiple tool operations. Minimal mode keeps only a persistent shell and a file editor. Creator mode adds runtime inspection, plugin experiments, and guidance for composing new presets. The last mode reveals the larger ambition. This is not only an agent, it is a system for building agents. This architecture also points toward a more speculative future. The Cordis paper names self-evolving agent harnesses as one motivation for dynamic composition. An agent that can inspect its runtime, test a new component, and roll back a failed change would need exactly this kind of lifecycle discipline. But that is infrastructure, not a safety solution. Reversible effects do not prove that generated code is trustworthy. Reactive dependencies do not prevent a malicious plugin from abusing the access it receives. Cordis may make controlled self-modification more practical. It does not make recursive self-improvement automatically safe. There are 3 more reasons to stay cautious. First, DeepSeek Harness is a developer preview. The project explicitly warns that its core plugins and interfaces will keep evolving, so production teams should expect compatibility breaks. Second, everything is a plugin expands the trust surface. Clean unloading can remove a plugin's effect from the runtime, but it cannot tell whether the plugin should have been trusted in the first place. Source provenance, permissions, updates, and supply chain controls still matter. Third, the documented sandbox is narrower than the word may suggest. Its modes govern file system effects. Network access and process visibility sit outside that vocabulary, and enforcement may be partial on some platform or kernel boundaries. The design does fail closed when confined execution cannot be provided, which is important. But workspace write access is not the same thing as complete container isolation. Finally, the Cordis paper itself is an actively revised preprint. Its production case study comes from one TypeScript ecosystem and is observational, not a controlled comparison against another architecture. None of those caveats make DeepSeek Harness unimportant. They clarify what it is today, an early, open attempt to turn the agent's execution layer into a composable platform. The first phase of the modern AI race focused on model intelligence. The next phase is increasingly about making that intelligence reliable in the real world, connecting tools, preserving state, supervising actions, recovering from failure, and letting developers reshape the system without rebuilding it from zero. DeepSeek is no longer offering only the intelligence inside the agent. It is helping define the runtime through which that intelligence acts. Whether this architecture becomes a widely adopted standard is still unknown, but it makes the direction of competition much easier to see. The model answers. The harness acts. Will the real AI moat belong to the best model or the best harness around it?